Hello friends, having discussed all about the broadcast networks, multiple access protocol, switched LAN, link layer addressing, Ethernet technology, switches and VLANs, link virtualization, that is MPLS. Here we reach to the last topic from link layer. In this session we will briefly discuss about data center. Data centers are simply centralized locations where computing and networking equipment is concentrated for the purpose of collecting, storing, processing, distributing or allowing access to large amount of data. They provide important services such as data storage, backup, recovery, data management and networking. In short, data centers is a pool of resources interconnected using communication network. Data center networks holds a pivotal role in data center as it interconnects all of the data centers resources together. In the recent years, internet companies such as Google, Microsoft, Facebook, Amazon have built massive data centers, is housing tens to hundreds of thousands of hosts and concurrently supporting many distinct cloud applications such as search, email, social networking or e-commerce. Each data center has its own data center network that interconnect its host with each other and interconnects the data center with the internet. Here we will cover the brief introduction of data center networking for cloud application. The cost of large data center is huge and about 40% of the total cost attributed to the host themselves, which needs to be replaced every 3 to 4 years. 25% to the infrastructure, including transformers, uninterrupted power supplies, generator for long-term outage, and cooling system. 15% on electricity utility cost for the power draws, and remaining 50% for networking, including network gears, switches, routers, load balancer, external links, and transmit traffic cost. Although the networking is not the largest cost, networking innovation is the key to reducing overall cost and maximizing the performance. A cloud data center such as Microsoft or Google Cloud Data Center provides many applications concurrently. For example, search, email or video applications. And to support the requests from external client, each application is associated with a publicly visible IP address to which the client sends their request and from which they receive the responses. Inside the data center, the external requests are first directed to load balancer as shown in the figure. The request is first goes to the internal load balancer, whose job is to distribute requests to the host, balancing the load across the host as a function of their current load. Large data center will often have several load balancers, each one devoted to a set of specific cloud applications. Such a load balancer is sometimes referred to as layer 4 switch, since it makes decisions based on destination port number, that is layer 4, as well as destination's IP address in the packet. Upon receiving the request for a particular application, the load balancer will then forward it to one of the hosts that handles the application. When the host finishes the processing the request, it will send back the response to the client. First, it will send back response to the load balancer, and which is in turn relays the response back to the external client. The load balancer not only balances the workload across the host, but also provides NAT-like functioning, translating the public external IP addresses to the internal IP addresses of the appropriate host, and then translating back for packets traveling in the reverse direction back to the client. This prevents clients from contacting hosts directly, which has the security benefits of hiding the internal network structure and thus preventing client from directly interconnecting with hosts. For small data centers housing few thousand hosts, a simple network consisting of border routers, load balancers, a few tens of racks, all interconnected by a single Ethernet switch could possibly suffice the purpose. But to scale to a 10 to hundreds of thousands of hosts, a data center often employ a hierarchy of routers and switches. One such a topology is shown in the figure. At the top of the hierarchy, the border routers connect to the access routers. Below each access router, there are 3 tiers of switches. For access router connected to a top tier switch, each top tier switch connects to a multiple second tier switches and a load balancer. Yet each top tier switch is connected to a multiple second tier switch and the load balancer. Each second tier switch in turn connect to a multiple racks via rack store. These are the rack store. Third tier switch. All links are typically use Ethernet for their link layer and physical layer protocol with a mix of copper and fiber cabling. With such a hierarchical design, it is possible to scale a data center to hundreds of thousands of hosts. This is all about basics about data center and data center networking. Thank you.